Let's get started. So, can you guys see that picture? Okay. So I'm actually here. My job is to introduce somebody who actually doesn't need to be introduced because otherwise you wouldn't be here, right? So Woody's going to talk. Who, as you know, was pilot on the Orion Crew 6 mission. Before we get started, I'm just going to embarrass him with a few things, okay, right? So as everybody, or most people here know, Woody was an undergraduate at MIT, okay, right? There is a video, but I won't play the video. So this is actually Woody's undergraduate thesis, or 1662 project, okay? So he flew a monocopter, right, which is a single wing rotary monocopter. And there's a video, you can look at it online, of him flying it down the infinite corridor, you know, with the RC flight. So he was an undergraduate here in AeroAstro. And then he, when he finished, he went to grad school, but he didn't actually go straight to grad school. So he went to Berkeley and then was in the Bay Area search and rescue. Bay Area
I was on two teams, but that was one of them.
Yeah. One of the teams, search and rescue. So he actually was a rescue climber at Yosemite when he was at grad school at Berkeley. Okay, and in Berkeley he got into a bunch of things in addition to climbing, but his sort of technical area was design optimization using convex optimization techniques there. And after a lot of hassling, and he'll have his own story here, came back to MIT, okay, and I had the privilege of teaching with him for a number of years. We taught, this was the aircraft design build course. So using the techniques that he developed, we actually designed an airplane. This was a airplane designed to fly for 5 days, designed and built it. Was originally supposed to be a solar airplane when it was spec'd out, but using the techniques of GP Kit in the modeling that we did, it turns out the engines here were good enough that you could actually fly it. So this was the airplane. You can't quite see in this picture. It launched off the top of the car. The car that we used for the launch was Woody's Mazda 3 there. And it's basically a flying fuel tank with a wing. So that we flew that. Now, one of the other things that we did when Woody was here, and actually even when he first went to NASA, okay, is I also had the privilege of going around the world with Woody on motorcycle trips, okay, right? And by the way, it turns out his having been a rescue climber and search and rescue turned out to be useful in a couple of situations, okay? And he's actually a good guy to have in your team. So this was actually in Peru, but we went to all kinds of weird places, and there's lots of stories there. Now, one of the things that would happen when you're out in the middle of nowhere, okay, with Woody, you'd stop to go to the bathroom or whatever, is Woody would do handstands, okay, in all kinds of places. So you can see this on someplace, you know, on the road, etc. So let me stop that. So we do all these handstands and whatever. So I actually asked him the other night, okay, it's actually, one of the interesting things is, so Woody, you can tell here, is incredibly strong and has an incredibly developed vestibular system, okay, right? So one of the things that happens when you go to space and come back is your vestibular system gets all messed up. So one of his ultimate recovery tests is when he's ready to go do handstands, okay, in remote parts of the world. Okay, the other thing is Woody is incredibly tough, mentally and physically and whatever. And one of the stories I'll tell about his toughness was at the end of a trip, we were in Peru, okay, and we had gone way into the boonies, okay, and we went so far in the boonies, it was the last night we were out, we went to a place where it was hard to get food, okay, so we were scrambling around to get food. We finally got to somebody who convinced them to give us some food, okay. We stopped at a place, and I was Woody's roommate. Middle of the night, Woody wakes up, and he's sick as a dog, okay? Okay. Now, you have to realize our flight out of Cusco leaves in 14 hours and whatever. We woke up at 6 o'clock in the morning, and there had been a snowstorm, so we had to go over the mountains in the snow, okay? So one of the toughest, I mean, this is a total gutted out. So, you know, we got him hydrated as much as we could. and like kind of buffered him and rode up over the mountain, okay? And I won't show all the pictures, but this is a picture of Woody after we made it over the mountain. This was like the first recovery. I mean, literally. So he left nothing on the table getting there. Okay, so I got plenty more stories that I can tell, but I'm not going to, because what you're really here to hear is about his mission and what's going on here. So I'm going to trade it over to Woody and do a hot swap here on the pictures.
Thank you, John.
Hey,
Thanks so much.
Here.
Thanks, guys. As I recall, we stopped every few miles for me to get into that pose.
I actually had a picture. No, though, he got to that pose, okay, and then like we hadn't had any food, right, for a long time. So we get to a town, and I do have another picture on my computer of actually the three of us were having, the other three guys were having breakfast, and Woody is literally lying on the ground in front of this restaurant, okay, sleeping.
All right, well, thank you. That was an amazing and kind introduction, John. So great to be with you, and it's just wonderful to be back at MIT. In many ways, this place still feels like home to me. In fact, other than where I grew up and went to high school, this is the place that I have still spent more time than any in my career. So it's great to be back. Just quick, I'll spend 5 or 10 minutes. I just have a few pictures telling much of what John hit on, just the path to becoming an astronaut and getting assigned to my mission. And then I have a video showing my mission up to the ISS a few months ago. I'll kind of talk through the video as it goes. This was growing up in Pittsburgh. I was really into building big rockets. I know we have a lot of rocket team, maybe some rocket team members in the room? Yes, sweet. Built a lot of big rockets. First exposure to just using my hands and building stuff. Many fond memories. Using my mom's sewing machine out in the middle of a field, fixing some parachutes. Parachutes would end up being a big part of my life. Actually, my first job ever was packing parachutes up at Skydive, Pennsylvania. And I got to do a little jumping too, but mostly I was just packing, rolling around on the floor, combating nylon.
He also did a couple base jumps too.
That's also true. I took unified engineering. There are 2 people in this photo in the audience, or in the room today, I think. Is that true? Yeah. So how many Course 16ers do we have in here? All right, awesome. Yes. And Professor Drell, I'm so sorry, but I have this photo too. It turns out he's extremely aerodynamic. Just had a great undergrad experience here at MIT in AeroAstro. As part of my time here at MIT, as John alluded to, I got into skiing. I was on the ski team, and I got into rock climbing. I did a lot of rock climbing. I was always off on the weekend, gone up in New Hampshire, climbing things and spending summers out in Yosemite climbing. And so I ended up with kind of these 2 parts of me. Part of me pursuing aerospace engineering and heading off to grad school, and then also part of me doing all this climbing stuff. And while I was in grad school, as John mentioned, I spent summers working search and rescue out in Yosemite National Park. This was my first experience with like a really tight-knit team, tight-knit operational team, which ended up being beneficial later in ways that I don't think I fully appreciated at the time. But just living with this amazing group of guys and gals, responding to emergencies, doing hard things together, and just being a good team. After grad school, I ended up being lucky enough to come here and join the faculty at MIT. And as John already mentioned, I'm not going to go into detail today, but my research group studied convex optimization formulations for design problems. We wrote a lot of software, and we were lucky enough to have an amazing group of students through teaching with John and also Professor Mark Drella. We ended up designing, building, and flight testing this airplane during my time on the faculty, and it was kind of one of the highlights, just getting to be involved in this project with all the students and get to use some of our software tools. And so it was right in the midst of this stuff, 3 years into being a young junior faculty member here, that I applied and was selected to join the class 22 of NASA astronauts back in 2017. Everybody in this photo followed a wildly different background. to be selected. I'm the only professor in the group. We're about half and half military civilian. Even on the military side, there's a few test pilots. There's 2 physicians, a Navy SEAL, submariner, helicopter pilots. Some of those jobs I just mentioned are filled by the same person, actually. And then the civilians are equally wide-ranging in the paths that they found through life to end up in that photo. Went off to NASA to astronaut boot camp and did about 2 years of training. This is the initial training that makes you eligible for a flight assignment. Got to spend a lot of time in the pool practicing spacewalking, geology training, International Space Station systems, learning to operate the Canadian robotic arm, just all sorts of cool stuff. And then a few years later, in spring of 2021, I got a phone call from my chief, and he asked me to be the pilot for the Crew 6 mission. A huge honor getting to do that. This is my amazing crew of 4 that started training together. We quickly gelled as a crew. So on the right side of the photo there is Sultan Al Nayati. He's the first long-duration astronaut from the UAE. Myself, our commander, Steve Bowen, shuttle veteran, and to Steve's right in the photo, Andrei Fadayev, our Russian cosmonaut. So we're doing seat swaps with the Russians. They fly cosmonauts on our Crew Dragon vehicles, and soon Boeing vehicles, and then we fly our astronauts on their Soyuz vehicles. And so we spent about 2 years training for our mission to fly up here to the International Space Station, up in low Earth orbit, about 250 miles above Earth. Just an amazing marvel of engineering. It's about 1 million pounds mass, fully solar powered. It's a couple hundred kilowatts of power generation. We actually augmented that as part of my mission. Closed loop life support system. I could go on and on about this marvel. It's one of the US national labs. And so now I will just switch over and go into video mode. And I'm just going to kind of walk you through the experience of training and flying the mission. So we gelled as a crew really quickly. We started about 2 years out from launch, spring of 2021. The training is super varied. This is in the neutral buoyancy lab down at Johnson, practicing just water survival, so getting familiar with all the emergency equipment that we have aboard Dragon. Should we need to land at an unsupported site, we have a life raft, so we can get out of the vehicle into a life raft and hunker down. We do a lot of aviation training. It is maybe one of the best analogs for the type of decision making and operational thinking that we need for spaceflight. So we have T-38 jets down in Houston, and they are a lot of fun. And then we have the Neutral Buoyancy Lab, also in Houston, Texas. This is the biggest swimming pool in the world by volume. It has a full-scale ISS underwater, at least most of the key parts that we might do maintenance on. We spend about 6 hours at a time in the pressurized suit, just practicing all of our tools and techniques for spacewalking. And then we also have a mock-up of the inside of Space Station, so we get decently high fidelity understanding of where everything is. We can practice maintenance procedures in here. We can do emergency procedures. We spend a lot of time in that building. And then I spent about a quarter of my life in the last year before flight out in Hawthorne, California, training with SpaceX for Dragon specifically. We got to drive MRAPs for emergency egress training. It was a lot of fun. And then, yeah, two years of pretty varied training, and we ended up in Florida for the last week on Earth before we would launch. So this was spring of last year, February. Went down to Kennedy Space Center, and we walked out about 3.5 hours prior to launch. This is the astronaut crew quarters at KSC. So there's a suit-up room down there, and this part is pretty choreographed. We're on NASA TV for all this, and I got a chance to kind of wave to my mom and brother. They were down there for me before I got in the Tesla vehicles that take us out to the launch pad. There's a tradition that you walk to this special spot and you do this super weird lean back, and you can see the whole rocket. And for us, this was about 2 a.m. in the morning, so seeing that beautiful rocket all lit up was incredible. And then we get in the vehicle, get strapped in. The suit techs Yeah, so we get strapped in, load up with fuel, and then we held with 2 minutes and 12 seconds prior to launch. We scrubbed our launch. There was an issue with the ignition system, this fluid called T-tab that lights our engines. So we had to pull all the fuel off the vehicle, disarm the launch escape system, and then 3 days later, we did it again. It's like Groundhog Day. Literally exactly the same thing. It turned out that initial try was a great training evolution. So we were a little more of a well-oiled machine on this go-round. But you never really know if you're actually launching to space or not. So we made it past 2 minutes, 12 seconds, and this time we actually went. So you definitely feel the liftoff. It's about 1.5 Gs, so it's fairly benign. Super smooth ride on the first stage with all 9 engines. And it builds up to about 4 Gs of accel at the end of stage 1. And then we light the second stage engine. This part feels a little rougher. It's like you're driving down a gravel road fast. And we again get up to about 4.5 Gs, and then that second stage engine cuts off. We separate from it, and we're weightless. And so this was my first significant experience with being weightless, and I would just be weightless for the next 6 months. We spent about a day phasing up to the ISS. And it was pretty special getting to see the thermal camera view of the ISS, this place we've trained for. I was super familiar with it by this point, but getting to actually arrive at this amazing place was very memorable. So crew 5 stayed with us for about a week, did a nice handover, and then they left. And we got super busy right away. The SpaceX 27 cargo vehicle came up about a week after we arrived. These cargo vehicles, particularly the SpaceX ones, because they parachute back into the ocean, so they can bring samples home. So those vehicles are full of all sorts of research for us to work on. We got to grow plants in weightlessness, grew some tomato plants. Sultan did a lot of work on this. It's really cool. We have an airlock over in the Japanese module, and we can send experiments outside using this airlock. So often it's used for CubeSats. We can actually launch small satellites into low Earth orbit from the ISS. It's really cool seeing those go. This is our minus 80-degree freezer, one of 3 actually. We have literally hundreds of samples moving around among these freezers and different cargo vehicles at any given time. Cardinal Heart was a super cool experiment studying new treatments for heart disease. And we actually, we were working with these heart muscle organoids, which age and degenerate faster in weightlessness than on Earth. So we're studying new treatments. And Sultan actually saw these beating through the microscope. If you look in, that was a special day, realizing we had beating heart cells in low Earth orbit. We're basically just operators up there. We work on literally hundreds of different experiments. The principal investigators are on the ground. There's usually a huge team of experts that are really interested in what we're doing. And it's quite varied for us. We're always working on something different. This was printing a section of human meniscus using this basically 3D bioprinter. It was the first section of meniscus printed in space. And this facility is going to be used to print some blood vessels in the near future. These are structures that can't support their own weight, so you couldn't do this on Earth. They have to be in a weightless environment. And so we do a lot of stuff on board, but all of the science work is definitely the purpose of why we're there. And we maybe spend half our time doing this type of scientific research, and then the other half of our time is spent on maintenance and just keeping the space station up and running, maintaining that beautiful flight vehicle. I actually hosted the Zero Robotics competition here at MIT. So student-run code operating these Astro B robots in the GEM. Okay, so that's kind of a science overview. I was lucky enough to do 2 spacewalks, and prior to that, I had the honor of being the suit IV, the person that suits up Steve and Sultan for a spacewalk that they did.
Copy. You are now go to egress the airlock. Sultan, you're making history today. Congratulations. We're so excited for you. Hope you both have a great EVA, and we'll see you in just a few hours.
And so Sultan was the first person from his region to ever do a spacewalk. And it was really special getting to see him do that. And so there's definitely differences with the pool, but I have to say I was blown away how similar the suit felt to how it feels in the pool. There's differences, like there's water drag in the pool that you don't have in space, but it was some really good training. That made me very prepared. About a month later, I headed out on some ISS rollout solar array installation spacewalks. That's me in the end of the robotic arm going for a ride. You can see the 2 rolls there of solar cell. The unit weighs 800 pounds on Earth. So it's 800 pounds of mass. You feel all that inertia.
We have our video back. Everything is looking great. I have 2 questions for you, Woody.
And this is a special part of the spacewalk, actually getting to see it roll out. So we did the 1 alpha power channel first, and then this was the 1 Bravo channel. It's a big day in mission control when we do an EVA. And this one's a little more complicated because the robotic arm actually doesn't reach the 1 Bravo install location. So I carried it out on the robotic arm as far as we could, and then Steve and I did a little kind of inchworm juggle to get the array the rest of the way out to the install location. That's Steve holding it while I reposition. And so this, in total, we added about 30 kilowatts to 2 power channels with those 2 spacewalks. We had a great crew, so in addition to my crew of 4 that came up on Dragon, 3 guys, Frank Rubio, Sergei Prokopiev, and Dmitry Petelin came up on a Soyuz. They actually had a leak, and so those 3 guys were stuck in space for a full year as a result of that leak on their Soyuz. And we sure had a great time together. Just all the shared meals, all the shared unique life experience of being up there together. It's amazing. This is Sultan running on our treadmill, which is mounted on the wall. So he's running toward the floor there. You load it up to something like 120 pounds of force. And we also played some chess games with Mission Control. They had a board down there. We had a board in space with little magnetic pieces and did maybe 1 or 2 moves a day. We spent a fair amount of time just sharing our work with folks around the world. So we do a lot of events there from the GEM on camera. One Sunday we did Space Olympics. We just made up games. And the food is super good, lots of variety, a lot like eating an MRE. We also sometimes get creative with things like pizza. Yeah, so we have a lot of fun outside of work hours. Toward the end of our mission, Crew 7 came up, and these are our replacements for my crew. So these guys arrived, and we spent about a week doing handover. In addition to all of that, I loved just going to the window and looking outside, often with a camera, sometimes without a camera. Sometimes I forced myself to just go to the cupola with no camera and just enjoy this remarkable view. Africa and the Middle East are like super striking with the orange sands against the water. The colors there are just unbelievable. We tried to set up cameras for time lapses like this one fairly often whenever we could, and we were doing an interesting pass, we would try to set up a time lapse. And then we do a lot of just straight up photography. There's also something called an international disaster charter site. So if there's a fire or an earthquake or a hurricane anywhere around the world, we'll get timelined to go take photos of it. And often an astronaut with a camera in their hand is the quickest way to get a view of what's unfolding during a natural disaster. This is down in, this is glaciers in the Himalayas, South America. Fires in British Columbia. And we did lots and lots of aurora time lapses. Night photography is really interesting and tricky. You have to go to a really high ISO. I learned a lot about photography while I was on board, just trying to get better shots. And it's funny, the work days are really long, but I tried to force myself to spend at least like 5 or 10 minutes in the cupola every night, just because even right now I miss this view. Let's see, my crew spent 186 days on board, and at that point it was time to come home. It was pretty wild just packing everything up and leaving home sweet home. You see our thrusters firing there as we back away from node 2 in the middle of the night. And again, we spent about 20 hours phasing before we did our deorbit burn. I'll say re-entry was incredibly dynamic. It was a wild ride. Once you do the deorbit burn, you are committed, you are going to re-enter. And so you're putting on the brakes. Imagine you're slamming on the brakes at 4 Gs for many minutes. We were basically inside a meteor. Total comm blackout because of the plasma surrounding the vehicle. And we come out the other side of re-entry. And at that point, you're basically a falling brick, close to terminal velocity, looking for drogue chutes. The pyros for these parachutes are really assertive. It's a big bang, throwing the chutes out. And you really feel each of these events. You could actually feel the drogues release, feel the initial main inflation, and then there are these disreefing events. So each one of these disreefing events, you can definitely feel the acceleration in the seat of your pants. And you can actually see here the cool parachutes and the hot capsule in the thermal camera. We landed in the highest seas to date of any US crewed vehicle off the coast of Jacksonville. We landed right after a storm. So we kind of pushed the envelope on what the program is comfortable landing in. And we get lifted onto this recovery ship out in the Atlantic. So we're still in the vehicle at this point. A lot of crews had talked about how dynamic it is being lifted on, but that was actually less dynamic for us than being in the water. That was an interesting difference. And we spent about 45 minutes doing some medical checks on the recovery ship, and then we get stretchered into a helicopter, fly over to Jacksonville. We did some science data collection right away in Jacksonville, and then we fly to Houston. So this is about 6 hours after landing. You can see everyone's keeping their head very, very still. The impacts on your vestibular system are significant. Anytime you move your head, it feels like you're tumbling. All right. So that's what I'm going to do is I'll let John moderate. I'm going to just throw up. I have these time lapses that are pretty pictures of Earth. I'll throw this up in the background, and we can just do Q&A. Does that sound good?
Yeah, yeah.
All right.
So, any questions? All right, go ahead.
As a pilot, to what extent were you in control of the Dragon's movements?
So for the nominal mission, meaning nothing is going wrong, we are not flying the vehicle, meaning we are not like directly controlling the flight path and attitude. We do send commands to the vehicle. So we tend to be, the crew is a gate for like proceeding to commanding flight computer state transitions. So we are commanding the vehicle in that sense, but we don't actually fly the vehicle, so to speak. I will say in training we get to fly the vehicle for several, that we practice all sorts of potential failure modes, and it gets really interesting in training. We had a failure on my vehicle, which I will, in the interest of time, not describe in great detail, but we had an unexpected failure that had never been seen before on Dragon. And we actually spent 53 minutes holding 20 meters from our docking port before docking due to that failure. And that's a longer story that would be fun to talk about.
Quick version, what was the failure?
So the failure was it's a failure of one of our docking hooks. We have 12 of them. They're the hooks that give us hard capture. One of them alarmed out with a like switch state error. It was a micro switch failure. The team quickly assessed that it's a hardware failure. The micro switch was broken, but then so the fix for that failure was to mask that micro switch from the logic that allows Dragon to do its state transitions. So there's some logic saying all the micro switches need to be in the right state, and the fix is just mask that one. We know the switch has failed, the hook's in the right position, and we'll proceed. Well, that was our plan, and we got to waypoint 2 with that software fix on board, ready to go, and we alarmed out at waypoint 2, like alarms blaring, warning, switch state conflict. So we ended up in I guess to briefly describe it, we ended up in a place where really nobody on the team expected that failure, which is interesting, I think. And the way we got there had to do with subtle errors in the initial conditions that were used to do the testing of the software fix. So this is like continuous integration stuff, testing code, and the initial conditions that were used for that testing did not actually quite match the state of the vehicle. So pretty subtle stuff.
Another question.
Yeah.
In the back, and then we'll come back to you in a minute.
With the overview effect, and how has that shifted your career goals or your life goals after this mission?
Yeah, so as probably everybody knows, the overview effect is this description where when you see the Earth from far away and get this broad overview, it kind of changes your perspective. I'll say low Earth orbit is actually pretty close to Earth. I dream of getting that view that Apollo 8 got, where you can't see the entire diameter of Earth from the space station. You can see the incredible curvature, that's your view. But Earth actually looks really big from low Earth orbit. So I think I was amazed how big that place is, and then the really, really like overpowering feeling for me was just looking at the atmosphere. When we go out on a spacewalk, it's pretty in your face that you are in a vacuum. And like, if you put your hand here, there's vacuum between your face and your hand. So there's just pure death all around you in space. And when you're up there, I mean, you're seeing the upper reaches of the atmosphere with the aurora there, but when you really look at the atmosphere, like Earth is protected from all that death by a very, very, very thin layer.
And has that shifted your career goals after?
I don't think it's shifted my career goals, no. I mean, it was an amazing life experience. I wouldn't trade it for anything. But I don't have like a profound insight for you. Yeah.
I feel like a lot of astronauts like focus on environmental stuff after
Oh, gotcha.
space. And so it seems like you've always been interested in space.
Yeah,
Or, sorry, in nature and the environment and stuff like
yeah,
that.
it's a totally fair question. Yeah, as a climber and someone who loves the outdoors, I've always cared a lot about protecting this place, and I certainly feel, if anything, only more so that way now. Yeah.
Question? Yeah.
During Unify this morning, you mentioned a lot of sim. Like, you were comfortable on the launch due to a lot of sims. I'm interested in like what types of sims did you guys look at, and like just the details in general. What were you looking for? What were the goals of those sims? What types of sims? Like, what did you run the sims on? Blah blah blah. Just like I'm just interested in what and how you guys prepare for the launch specifically. Like.
And you mean the launch specifically?
Just the simulations.
Yeah.
I guess.
So I think the way to think of this is we get all this training, and each piece of the training prepares us in some way, and we also kind of mentally integrate all those experiences to make ourselves ready to fly. So for launch being one example, we go out to Hawthorne and we sit in, there's a very, very good high fidelity mock-up of Dragon out at Hawthorne. It's called the Buck. And we go in there and do launch profiles. The training team throws malfunctions and errors at us. We have to respond. High fidelity mock-up of the vehicle itself. We respond to emergencies. We get on masks. We fight fires. We deal with depress cases. We get in our suits. The suits actually pressurize in there. So we can deal with kind of life inside Dragon. Now, one thing we can't do there is accelerate at all. We go to Wright Pat and get in the centrifuge, and we actually get to experience a launch profile sitting in the centrifuge. Now that centrifuge doesn't have anything, it looks nothing like the inside of Dragon. You're sitting in a chair in a box. It looks nothing at all like Dragon. But we get to do an actual launch profile and feel exactly the G's that we'll experience during launch. So this being one example, I was always in the back of my mind trying to correlate, like when I saw 3 Gs on the displays out in Hawthorne, I'm just sitting in a chair. I'm not at 3 Gs in training. But I knew what 3 Gs felt like from the centrifuge and how I would be feeling. And I always tried to kind of play that realistically. You know, it's going to take a moment to reach for the push to talk button. It's going to be a little harder to move. I'm not going to be thinking quite as quickly as I am just sitting at 1 G. So that's just one example, but where we try to bring together these different experiences. Now, all of them are simulations. They are not perfect replications of reality, but we try to combine them all to be ready to fly. Yeah.
Question over here.
After having pursued an undergrad in AeroAstro, why did you choose to move to ECS in Berkeley?
Thank you. Great question. And this will show you how unplanned my trajectory through life was. So I finally decided to sign up for AeroAstro because I was walking through Building 33 and there was a giant poster of Tom Cruise in Top Gun. And I thought, these are my people. And so I did AeroAstro. In my maybe senior year as an undergrad, I was getting really interested in artificial intelligence, machine learning, and robotics. And that was just, I thought those were really cool areas. And the top grad programs in those areas are all in computer science departments. So I went off to grad school with the intent to study robotics. Through that, studying robotics and actually working on robotics in the first year or so of grad school, I was taking some math classes and learned about this thing called convex optimization. And it turned out that I was really glad that I ended up studying in two very different fields, because learning about convex optimization made me have a bunch of insights about how that could be useful for problems in aerospace. And I was able to connect those back together and kind of wound up back in aerospace. But I never expected, when I went off to grad school to do robotics, like I thought I was gonna stick with that. I didn't think I would be going back into aerospace. And then I did, and it's good to be back.
Other questions? Come on.
Ernie?
Gary.
When the clock starts ticking down like 10 seconds to launch, like what went through your head, like explicitly at that moment?
This was what, I had a few surprises. This was one of the big surprises for me. I kind of got a flavor of it when we scrubbed, because we made it to 2 minutes and 12 seconds. And I kept thinking, like, sometime in the future, you will get nervous. But right now, this feels just like a training sim, and like I know the next thing that's gonna happen, and I'm not nervous yet. But maybe after that next thing that happens, I'll get nervous. And I mean, there's a lot going on. We're loading prop. We have to arm the launch escape system. But honestly, like with 10 seconds to go, I was surprised that I wasn't all that nervous. And it felt exactly like a sim. The training was really good. I was just like ready to monitor. We have a bunch of stuff we're monitoring during launch. We have a big launch escape handle right between us that we will pull if we have to. And yeah, it felt just very routine and a lot like training. Yeah.
Did you experience brain fog during your long duration mission?
Yeah, and brain fog meaning like, what do you specifically mean by brain fog?
So like, kind of like when you realize like maybe like a slowness and like how you normally would function, and when you get like neurological. Yeah,
we all talk about that a bit. And I think I did experience that a little bit. It's hard we actually were wondering if it has to do at all with CO2. The CO2 levels on the ISS are about 10 times on Earth. And that's apparently a safe level. It's like, I'm not going to quote it because I want to get my units right, but it's about 10 times the CO2 concentration here. We talk a lot about CO2 pockets, and if you spend a lot of time in high CO2, we actually do training where we intentionally breathe a bunch of CO2 just to figure out what our personal symptoms are. And I think one for me is that kind of a little bit, I get a little slow. Not that I'm already a little slow, and then I get like a little bit, yeah. So I don't have any good specific examples for you, but every once in a while I remember thinking to myself, like, I'm not sure I'm all that sharp right now. Yeah.
There's a question here, and then I'll come back. Yeah. You got it.
Can you expand upon how your time in the search and rescue team in Yosemite, how you felt like that prepared you for being an astronaut?
Yeah, absolutely. I felt like that was my first experience just doing what I would call really operational stuff, like getting called out for a mission to go save someone or respond to whatever the emergency is. Doing it with a tight-knit team that worked really well together. And I think I had that side of me that really enjoyed those types of activities, and it could be anything. It could be rescue, it could be like working on boats, whatever it is. But a lot of the civilians that end up getting selected at NASA have something that we would call operational in their background, in addition to whatever their technical kind of area of expertise was. Now for me, going through life, I always felt a little bit conflicted and like I could never quite combine those two sides of me together. So this job is the first one where I felt like I really can combine those sides. But there's probably other great ways too. John does a good job of combining those sides as well. So, yeah.
Can you talk about the lessons learned you had working on this team, training with them for 2 years and going up on the ISS with them for 6 months, and your biggest lessons learned, how you ensured your team cohesiveness stayed intact, and how you managed conflict?
Yeah, that's a great question. And I think I feel very lucky that in the astronaut corps, everyone is really intentional about addressing kind of what you're hitting on there. First of all, I think we're set up for success in that we're tending to select people that tend to be good team players, that have a part of them that just wants to be a good functioning member of the team. So we already have good people to start from. That's true more so now than maybe a few decades ago, because the missions are longer. It is a focus that we have people that are going to get along for months at a time. On my team, on my crew, we were just really pragmatic about it. First of all, just bringing it up, so finding opportunities to like have a quick debrief, and it's really quick. Like we would just gather on Friday after the work week and say, we would literally say, does anyone have anything? And that kind of meant, you know, is there anything on anyone's mind? Have you noticed any like little things we're doing that we could do better as a team? Anything that we're finding annoying? And it could be like super little things like, hey, I noticed that there's a lot of drink bags being left around. Can we try to clean those up a little better? Just actionable stuff, but just creating opportunities to kind of bring up what might be bugging people. So I was lucky on my crew, we didn't have major conflict. We didn't have any like clashing personalities. I think everybody got along really well. And Frank Rubio was our USOS lead. So during my increment, the station commander happened to be one of the Russian cosmonauts. That kind of switches back and forth. But we have a leadership role on the US side. Frank filled that role, and he did a phenomenal job of just kind of every week saying, let's just gather for 5 or 10 minutes, talk as a crew, and then we'll move on. Yeah.
Question, yeah. I'll come back.
Yeah. What kind of like insights did you learn from living in like microgravity environment for like 6 months?
Well, very practically, it's amazing how useless you are at first, just with all the little things. I mean, you have a bag of items, and you want to find one item in the bag. How do you do it? And so, like, it's very practical, but like you open the bag and stuff starts floating out, and like, and so you have to learn to kind of deal with literally all the stuff you're working with. Tools, finding ways to secure your tools as you're working with them. And none of this is hard, but I certainly learned a lot about just being efficient, kind of dealing with this wildly different environment. Humans are amazing. Like the adaptation is impressive, how quickly you adapt. Yeah.
I have 2 training type questions, or maybe 3. I assume you talked to previous crews before you. Were there things that you were surprised that they didn't tell you? That's the first question. And then I guess, I'm not quite sure how to phrase the question. How structured is the training versus like you're going to get experience in this bucket and experience in this bucket, and you kind of have flexibility in that?
I'll spend most of the time on the second question. I don't have any I can't think of any like huge surprises that I think through the training and talking to other crews, I had a pretty decent idea of what to expect. Now, nothing could possibly prepare me fully for the actual experience, but there wasn't any wild surprises. On the training, it is qualitatively different than the shuttle era. So we're doing these 6-month missions. On shuttle, you knew that on day 8 of the mission, this was going to be your rough timeline. You had been preparing for that for months. You knew exactly what you were going to be doing. I couldn't have told you on day 96 of my mission before I launched what I was going to be doing. So in that sense, we do train much more generically right now, and we also select people that are kind of more broad and can just do a lot of different things. We do train very repetitively and very intentionally on the aspects that are either perishable skills or that are just critically important. So we spend a disproportionate amount of time training launch, docking, undocking, re-entry, spacewalks. And I'll also say operating the robotic arm happens to be a somewhat perishable skill, so we do refresher training on that. But then there's other things like maintenance activities where if you know how to use tools and follow a procedure, you really don't need training.
Question, yeah.
I want to know what was your experience like being part of the international group of astronauts where you all had different stakeholders, like you being with NASA and some of your teammates with different agencies?
Yeah. We have, so I mean, I'll say that the station is operationally, the volume is shared, hatches are open. We all meet up as a crew of 7, like everybody on board for dinners, and we have a great time as a crew. Operationally, during the workday, the Russian segment, which is about 1/3 of the volume of the ISS, the Russians do their work controlled by Moscow, and it is basically separate from the other 2/3 of station, which is essentially everyone else. So in my case, this was my crew and Sultan Al-Nayati from the UAE. So we had Frank, Steve, myself, and Sultan. Right now up there, there's 2 American astronauts, 1 Danish astronaut, and 1 Japanese astronaut. So there's always kind of an international complement on that US side. The US side is operated, Houston is running the show basically, and then we also have the other control centers around the world supporting their activities. But we all kind of function in the same way. I'm not, like, we could get timeline for any activity. We're interchangeable in that sense. Now, like Sultan did a lot of PR events for his home space agency. That was part of his mission. So he spent a disproportionate amount of time doing that type of work. But other than that, we are all kind of responding to the same flight control team in the same way. Is that what you were getting at, or? Okay.
Other questions? Yeah, in the back.
Talk about how you adapted to life in the ISS, things like sleep schedules, personal hygiene.
Yeah, it's just a steep learning curve for the first, I would say, week or 2. You adapt pretty quickly just by necessity. Sleep schedule is actually surprisingly straightforward. We operate on Greenwich Mean Time. It's a 24-hour day. I got up at 6:30 every morning. I went to bed at like 10. It's just a standard work day. Stuff like hygiene, the first time, you're just kind of figuring it out. We can talk more about that, but yeah, it's just steep learning curve by necessity.
Yeah.
Yeah.
Over here.
One question I have is, how have you fortified your mental resilience? Have there been any mental practices, routines, or just general perspectives you have on life that have helped you?
I'll see if I have the right words to describe this. One insight that came from me while I was on board, I felt very lucky to be in this position where there's a lot of eyes on us. Like, there are hundreds of people on the ground literally watching what we're doing. And so there's a bit of pressure there. And specifically, when I started, it felt like there was a lot of pressure to not make mistakes, like to get things right, to be efficient. There's just a lot of eyes on you. I found it very liberating as I kind of grew during the mission. I realized, first and foremost, like, everyone in space makes mistakes at some point. And it could be a minor thing, but you're gonna make a mistake. The idea that you could go up there for 6 months and not make a mistake is just not possible. I found it super liberating to realize that like, that's actually okay. You just fess up about it, like, be open. Hey, I messed up. And then what the insight I had was, like, I'm lucky that I get the rest of the day and the rest of the week to try to not make mistakes. Like, I'm still in it. Even though I made a mistake here, it's fine, because I'm gonna, like, I still have plenty of opportunity to do a great job. I'm not sure if I'm articulating that clearly, but a lot of growth for me around just, like, the idea that I'm not perfect, but that's actually good and fine and normal.
Okay, we're about at the end, so I'm going to do the last question. All right.
So you've done a long mission now. How different would it be to do a longer mission to Mars, let's say?
Yeah.
Do you think you'll be selected, and would you want to?
I think, so a multi-year mission to Mars is a serious commitment. That's a long time away from home. I think that it's easier to do that if you know what you're signing up for. So my crew specifically, like, I give a huge amount of credit to Frank and his 2 cosmonaut colleagues. They were within 2 months of time to come home when they found out that they were getting extended for 6 months. And there's just, it probably sounds like, well, that's great. You get to spend 6 extra months in space. That's awesome. But it's just hard to get that type of news that what you thought was going to be happening in your life is just radically different than the reality of what's going to happen. So I think late-breaking changes and like unexpected major changes to timeline are much harder than if you know in advance what it is you're going off to do.
Right.
Yeah.
So we're over time, so I'm going to take it. So Woody, thanks for actually coming to MIT and the brief and the whole thing. And so let's thank him.
Thanks for hosting, John. Thank you.